Hello, students. Welcome to another live edition of our MA 280 Computer Appreciation, in this case, MATLAB. And we've dealt with Chapter 1, that is the introduction to MATLAB. Chapter 2, perform some basic matrix operations. And we are now on Chapter 3, and that is where we get to see some nice graphics. That is the data visualization aspect of MATLAB. We are going to see some of the amazing plots you are going to come up with using MATLAB. Okay, so with this, we could think of plotting a line. Okay, where in this case we are going to plot what, some vectors together. Okay, so in this case, we could use the function plot. Okay, so suppose that we have two vectors, that is x and y. Okay, we could plot these two vectors together as we've seen here. Okay, so in this case, for us to plot these two vectors, we use the function plot. Okay, so that is exactly what we see in here. So plot the first vector and the second vector. Okay, so once we use plot x and y, this is just going to give us what, this information as we need here. Okay, but suppose that we like to add what, features or more features. Okay, we can use the x label to label the x-axis, y label to label the y-axis, the title that will give us what, the main heading, and if you like to what, introduce what, a legend, we could just introduce what, this function legend, and specify the let's say the legend, how we like the legend to be called. Okay, and suppose that you like to see this grid, that we have. Okay, this kind of small boxes that we have here in there, we could use also the function grid. Okay, so let's see how we get to demonstrate this. Okay, so suppose that let me clear my console for now. Okay, so suppose that I should have my first vector. Let me try to create any random vector. Okay, so with this, I'm going to create vector A, and in this vector, suppose that I should have, let's say, let me create 1 to, let's say, 10. Okay, that is going to be my first vector as we see in here. Okay, and for my second vector, suppose that I would like to have random numbers. Okay, let's call this any random numbers. In that also, I need somehow like 10. Okay, so that is my random number, but this is somehow a 10 by 10, which makes it somehow huge. But let me try to just create a column or a row vector. Let me just clear the screen. So we have our A. Okay, then let me create any vector. So let's say that the first instance, the age of people. Okay, so let me create the first one is let's say 5 years old, the second one is 25, the next one is 75, and with this one, let's call it his, let's say 45, and the fifth one is 22, the next one is 2 years old, the next one, let's say 19, the next one, let's say is 55. Okay, the next one, let's say he's in early 18. Okay, so we have 1 2 3 4 5 6 7 8 9. Yeah, and the last one, let's say that this guy is 33 years. Okay, so this happens to be our B. Okay, beautifully done in there. So suppose that you would like to plot these two vectors together, we could use the plot. Then we are going to specify our first vector, which is in this case A, and our second one happens to be B. So once we do that, MATLAB is just going to plot this for us. Okay, this will just come in a jiffy. Okay. Yeah, so voila, that is it. Okay, so MATLAB is just going to plot these two right away for us. Okay, yeah. So with this, you can see that this is in the original form, raw state. Okay. However, if you would like to introduce the x or label the x axis, in this case, let me call the x level as should I call it let's say subject. Okay, so I'm going to call this using the function x level. Okay, and I'm going to specify the name I would like to call it. Okay, so this I'm going to call this subject, referring to the x-axis. And once I do press enter, this will be effected on the plot. Okay, remember that this has been open in another window, so anything that we do will be just affected on the next window. Okay, so that is what we have in here. Also, we could also add the y label. So in this case, y label, and in this case I'll call it, let's say, age, or let's say age of subjects. Okay, okay, so once we do that, this gets to appear on our plot as we see in here. Okay, suppose that you like to also label this. Okay, or show a legend for this data, you could use the function legend, or legend as that. But before we get to the legend, let's try to include a label that is a heading on top of what this plot. And in this case, we are going to use the function title. And in this case, I'll prefer the name, let's say, plot of age of subjects. Okay, so once we do that, we just hit enter, and this will just be effected up here, as we can see. Now let's introduce the legend using the function legend. Then we specify what the legend should be called. Okay, so in this case, I would like to call it, let's say, my series. And once I do that, this will be effected, okay, on that, and that is what we see as we have in here as legend. Okay, now we can think of including this grid, and this grid will introduce that square boxes. Okay, and this will make it somehow easier to trace these numbers to the axis. Okay, so you could add all these features to any plot that you require. Okay, so this is basically how plot is being done using MATLAB. Okay, now what if you should have two separate series that you like to plot all in one same plot? Okay, so in this case, suppose that we create a vector that is a linspace. Okay, remember we did talk about this linspace, how to create this sequence. Okay, that is, in this case, we are starting from 1 up to 2 pi, and in there we need about 1000 points. Okay, so this is what the linspace is going to create. And in also, we are going to find or create a new variable which will be evaluated based on sine of this x. Okay, now remember, this x is about 1000 sample points or 1000 points. So once we find sine of x, this is going to find the sine of x of each of these points and assign it to y1. Okay, now our next variable, which will be y2, will be the cause of all the x's again. So this will determine or estimate or evaluate the cosine of all the points in x and just assign everything to y2. Okay, so in this case, before we can plot this, we have to use what? The plot. Okay, so in this case, the plot, that is for the first series or the first data set that we are going to plot the x against the y1, followed by the same x, then the second one sequence. Okay, so this two is going to first take care of what? This this sine, and the next one is going to take care of what? This other cosine. Okay, so this is how we get to plot two or more plots. Okay, however, if you should need more, you could use x2, x3. Okay, in that same order. Okay, so this is as simple as that. And once the base of this plot is being done, you could just think of what? Adding these features to it as well. Okay, now what if you like to plot with two separate what axes? Okay, now with this it's also easy. Now in this case, we are coming up with a sequence from -10 to +10, and their increment is what? 0.1. Okay, so this is just going to create the sequence for us, and we are thinking about creating two variables in which one will be computed based on the functional evaluation for each point we have in here. Okay, and y2 will also be evaluated based on this function that we have here. Okay, so this is basically going to pick the values of x and just place them in, and we are going to get a whole long string of data. Okay, so let me try to do this simple one. Okay, so suppose that we have this. Okay, so in this case, we should have numbers, let's say x, or let me try to clear the screen first. Okay, so in this case, we have x being equal to a sequence from -10, -10, with an increment of 0.1 to 10. Okay, and that is the end value. Now once we do this is what we are getting. Okay, so but because it's too cumbersome, let me try to compress this using the semicolon or suppress the output. Okay, now, and also we like to estimate these new parameters. Okay, and that is the y1 and the y2. Okay, all right, so let's try to enter this in MATLAB. So for y1, we have sine of x, then element-wise division of x, then finally element-wise raised to the power, element-wise raised to the power 2. Okay, now let me suppress these two, because this, if I should press enter, this is just going to give me so many output. Okay, so once I do that, that is also done. Now let's try to estimate our y2. Okay, and in doing so, our y2, remember from the lecture material, y2 is equal to 3 sine absolute of x. Okay, so let's just try to enter this in there. So this will be equal to 3 times sine of absolute, that is the abs of x. Right, now let me suppress this output too. Okay, so it's going to give me something so huge. Okay, so with this, now that we have our argument in there, let me try to use the whos so that we get to see the properties of that. Okay, so you can see that for our x1 we have 1 by 201. Okay, so that happens to be the dimension of our x, y1 and y2. Okay, as simple as that. Okay, so now let's get to see how we get to plot these two on separate one y-axis. Okay, so in doing so, we are going to make use of the function plot y, and we are going to specify the x-axis. That is, in this case we have it to be x, and we specify the first one, which happens to be y1. Then comma, we specify our x again, and secondly we specify our y2. Okay, don't forget your commas. Okay, so once I do hit enter, this is just going to plot our plots for us. Okay, and as you can see, we have it beautifully done in here. Okay, simple as that. Now if you like to introduce the legend, the x-axis, you just go ahead to just do that. Okay, and remember, any code that you type in MATLAB is being saved, so you can just use the up arrow key to revisit any code. Okay, so suppose I would like to visit this label code that I just did some time back. I just press enter, and this is just going to just label that. Okay, in that same case, if I need my x label and that, I can just type them in, and MATLAB will just do justice to them for me. Okay, so that is how we get to do that. Okay, so what if you like to develop a bar plot, a bar chart? Okay, you could also do same. Okay, so for instance, with our data that we had earlier, you could use the function bar. You specify the inputs, that is the x as well as the y and their frequencies. Okay, and this is just going to give you the bar chart. Okay, so let's take it as we have our first one. Okay, we have, remember, our a and b. Okay, we did include this earlier. Okay, we can develop our bar chart with it. Okay, so we could just use the function bar. Let me try to clear the screen. The function bar. Yeah, so function bar, then we specify our a and our x and our y. Okay, and remember, our x-axis happens to be the a, and our frequencies, although not so great, but let's use our frequencies as b. Okay, so once we do this, this is just going to give us a very nice bar chart. Okay, as simple as that. So with that, let's get to see it. Yeah, so this is a beautiful bar chart as we have in here. Okay, as simple as that. Now you could also come up with turn it horizontal form. Okay, so in that same case, all that you have to do is use the function bar h, referring to the horizontal form of what that. Okay, so we could just use bar h, and this is just going to give our plot to us in the form of what horizontal bar chart. Okay, now in that same case, we could plot our data in a polar coordinate chart. Okay, so all that we have to do is just use the function polar. Okay, and this is going to plot everything in the form of a polar coordinate chart for us. We could also plot the area. Okay, and that is the area of x and y using the function area. So you specify x and you specify y, and that gives you your area. You could also plot the quiver plots, and that is exactly what you see in here. Okay, so in this case we are using the function quiver. Okay, you specify x and y, and that gives us our quiver plot. We will also plot ribbons. Okay, and that is our ribbon using the ribbon function x and y, and that will give you this nice plot that we have. We could also plot in the form of a stairs. Okay, and we use the function stairs, and this is just going to plot them as we have in here. Okay, we could also plot our stem and leaf. Okay, and we use the function stem, and this will plot this beautifully for us. So this is our stem. We use the function stem, specify x and y, and that is beautifully done right here. We could also plot using our pie charts. Okay, and remember, with our pie chart we need only one vector. Okay, so in this case our pi of our x and has been divided beautifully in there. Okay, we could also do our semi-log plots. Okay, now once we use semi-log x, okay, it means that the axis of the x-axis will be what transformed using the log. Okay, so in this case we have these two vectors, that is x and y. So once we use the function semi-log x, this is just going to find the logarithm of this input of the vector x, okay, and just plot it. Okay, so you can see that in this case we have the logarithm of the first input, the logarithm up to the last point as we see in here. So this is just going to plot this one. Okay, now in cases where we use semi-log y, this is just going to log the x y axis. Okay, that is the vector of the y-axis. Okay, so this will be logged, and that is exactly what we see in here. Now when we get to use log, this is going to log both axes. Okay, so this happens to be our vectors. So once we use log, this is just going to log them, and that is exactly what we see in here. Okay, now let's get to see how we get to do subplots, that getting to have so many plots on one same figure. Okay, now remember we did something similar where we get to use the function imperflow, okay, to do that. Okay, so in MATLAB we are going to use a function called the subset. Okay, so we are just going to demonstrate this as we see in here. Okay, so in doing this, let me try to get hold of some data. Okay, all right, so let's try this in MATLAB and see what happens. Okay, so in MATLAB, let me try first of all to clear the screen. So with this, let's try to create any random sequence of numbers which will be our x. Okay, so suppose that we like to use the linspace to create a sequence of numbers starting from 0 up to, let's say, 2 times of pi. Okay, as you have in your lecture material. Okay, and we need about, let's go 2000 points. Okay, yeah, let me suppress the answer. So that is that. Okay, and before we could do that, let's try to create some variable, let's say about 4 of them. Okay, if you like to create 2, if you like to create, it depends on the number of plots you want on the figure. Okay, so going by the lecture material, let's try to create 4. Okay, so we are going to create 1, 2, 3, and 4 other variables, which will be our y. Okay, so let's create the first one, that is y1, which in this case is the sign of our linspace. Okay, but before we get there, let's try to assign this linspace to a variable called x. Okay, so that we could fall on this anytime. Okay, so introducing our y1, which happens to be the sign of x. Let me suppress this. Let me create another variable called y2, and this happens to be the cos of x. And y3, let's call this the tan, equal to, tan of x. Let me suppress this output too. And the last one, that is y4, and we have the cot of x, cotangent of x. All right, let me suppress this too. Okay, So once I press enter, we have all these parameters in there. Okay, so let's use the whose function to see the dimensions of y. So you can see that x is a 1 by 2000, y1 up to y4, they are all x by 2000. Okay, and they are all double. Okay, floating point. Okay, so let's see how we get to plot these. Okay, now suppose that with our plot we like to plot our first y1 in the first plot, y2 in the second plot, y3 in the third plot, and y4 in the fourth plot. Okay, so with this we are going to specify the function subplot. The function subplot, and we are going to specify the dimension. Okay, and because we are trying to plot 4, okay, we can think of what a 2 by 2, we can think of a 1 by 4. Okay, however you like to do it. Okay, but let's plot a 2 by 2. Okay, so meaning that I need 4 boxes, 2 up, 2 down. Okay, so that is what is happening here. So the next entry will be the location. Where do I want the first thing to be located? Okay, then I introduce a comma and I'll tell MATLAB to plot x and the first one, which is happens to be y1. Okay, and once I press enter, this plot will be delivered right here. Okay, so you can see that the interface has been created and the first one has been allocated to the first space that we have in here. The second one will appear here, third one will appear here, fourth one will just appear here. Okay, yeah, so in this same case we can just go back to this formula and modify this formula. Okay, so in this case we are still on the 2 by 2. By this time we are moving on to the second position, and with this one we like to plot y2. Okay, so once we do this and we press enter, they're just going to plot the second one as we have in here. Okay, now we could do the same for the third one, and remember with this third one we are looking for the third position, and in this case we are plotting y3, and once we do that the y3 just appears, and finally with the last point we need this to go into position 4, and we are dealing with the y4 this time, and once we press enter we have everything in here. Okay, so this is how we get to assign or plot different plot all in one same figure using the subplot command in MATLAB. Okay, so this is how it is being done. Okay, so this brings us to the end of our chapter 3. Okay, and I hope that this section is needs a little more of practice. Okay, so you can think of generating any sequence of your choice and begin to plot this at your own time, just as a demonstration. Okay, so this brings us to the end, and I will see you guys in the next lecture. That will be the chapter 4. Okay, so bye for now.